The purpose of this video is to show you how to service and repair a petrol mower engine, using a Honda HRJ 216 as an example. It explains the basic steps and tools needed so students can understand how small engines work and how to maintain them safely. How petrol engines work. Engine block. This is the base of the reciprocating internal combustion engine, usually made of cast iron or aluminum. It has cylinders for the pistons to be inserted into in different arrangements and amounts. In a line for straight engine, have two rows of cylinders in a V-shaped arrangement, or a flat or boxer engine where the cylinders are fully horizontal. And W engines with 2 or 4 rows used in cars, and 3 rows usually used for internal combustion airplane engines. Single-cylinder engines or thumpers don't have a layout and are commonly used for light machinery like lawnmowers or small motorcycles. Piston and connecting rod. The pistons are short cylindrical parts usually made of aluminum in smaller engines, cast iron in larger engines, and in performance applications titanium or forged steel. One end of the piston has a connecting rod that connects the piston to the crankshaft through a gudgeon pin, which allows the connecting rod to pivot as it transfers the up and down movement of the piston to rotational movement to spin the crankshaft. The other end of the piston is called the crown, which has different shapes chosen on by things like the ratio and efficiency of the engine's compression. The sides of a piston will have some number of slots, each filled with a metallic split ring that seals the combustion chamber from the crankcase, where the crankshaft is, and the oil in the oil sump, and prevents most of the gases from leaking into the crankcase and oil into the combustion chamber. 1. Induction. Beginning at TDC. During this stroke, the intake valve is in the open position and the piston produces a partial vacuum, aka negative pressure, in the cylinder, which pulls the air-fuel mixture into the cylinder through its downward motion, aka intake or suction. 2. Compression. Begins at BDC, just at the end of stroke 1. In this stroke, the piston gets pushed back up to TDC, caused by the rotational force of the flywheel, or flex plate for engines with an automatic transmission, to compress the air-fuel mixture in preparation of the spark plug's ignition in the next stroke. Both valves are closed during this stage. 3. Combustion. This is the start of the second revolution of the 4-stroke cycle. At this point, the crankshaft has completed one full revolution. While the piston is at TDC, end of the compression stroke, the compressed air-fuel mixture is ignited by the spark plug or by heat generated by high compression in diesel engines, forcing the piston to BDC. This is where the piston produces mechanical work from the engine to turn the crankshaft, aka power or ignition. 4. Exhaust. During this stroke, the piston starts at BDC. While the exhaust valve is open, the piston once again gets pushed up to TDC by the flywheel to expel all the now spent air-fuel mixture out of the cylinder and into the exhaust port to either go through the exhaust system, usually to get the harmful toxins converted into less but still harmful carbon dioxide, usually cars, trucks, and buses, or straight into the air, usually petrol motorized equipment like mowers, weed whackers, and chainsaws.